Hello and welcome to this Food Tech webinar. My name is Rich North and I'm a Senior Manager with IHS, and I'd like to review a few housekeeping items with you before we begin. Let's take a moment to familiarize ourselves with the operation of the user interface for today's webinar. The large window with the heading Food Tech Presentation in the upper left, that's the primary window for today's webinar. Now just to the right of the main presentation window is the speaker's bio window, with background information on today's presenter, John Schnell. Just below that is the Q&A window, and at any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will then be placed in the queue to address when we get to that Q&A session. Now at the bottom of your screen, you'll see 8 buttons. The first 3 either minimize or restore the 3 windows we've already talked about. The others allow you to share your webinar experience using social networking tools, take a survey to provide feedback on your webinar experience, access Facebook and Twitter, and do a little troubleshooting like running the system test or consulting the FAQ document. Now, if you can't remember what a particular button does, just hover your mouse pointer over it and a tooltip will appear with a description of the button's function. And now to get this webinar started, here's Senior Sales Engineer John Schnell. John?
Good morning or good afternoon, depending on your situation. My name is John Schnell. I am a Senior Sales Engineer with FUTech Advanced Sensor Technologies. And first, we'd like to thank you for taking time from your busy schedule to attend our webinar. Today's webinar will address automation using miniature load cells and our USB solutions. Today's agenda will include core competency and then certifications, miniature load cell overview, our USB solutions overview, and most importantly, automation applications. What we hope to share with you today and give you significant takeaways will be embedded applications as they apply to automation involving the use of the load cell and the USB solutions. And then, of course, we will end our session with a question and answer period. Before we begin today, I would like to give you an overview of FUTech. FUTech was founded in 1988. We are a privately held company. The product line includes load cells, reaction torque sensors, rotary torque sensors, pressure transducers, instrumentation, multi-component sensors, and software. Today's discussion will focus on the LSB 200 miniature S-type load cell, our USB solutions, and our Sensit software program. I'd like to point out that the Sensit software solution was established as a common platform for all our instrumentation, offering compatibility with all our digital instruments. However, it is important to note that FUTech offers over 3,000 product solutions, providing automation systems for aerospace, automotive, medical instrumentation, and general industry, just to name a few. In addition to our standard product offering, we also offer custom solutions with a focus on the OEM solutions. And an important aspect to our OEM business is that we maintain in excess of 98% on-time delivery with a zero-defect quality culture philosophy. All right, before we get started, I want to take a few minutes and just talk about our certifications. FUTech is ISO 9001, 17025, Z540, and 13485. I believe this is an important issue from the standpoint of the standards that we work to, and also for you, the user, to understand that you're working with an organization that insists on the highest standards and offers extremely high quality. The other thing that I wanted to point out was our RoHS program. We have RoHS capable or compliant products, and we have an objective in 2014 to expand our RoHS capability, at the same time providing non-RoHS for those critical aerospace clients. Before we get started, I would like our audience to be patient with me. I want to go through some of the details of load cell technology and load cell significance to give you a clear understanding of the front end component of this solution. This is important so that you understand the mechanical characteristics of the sensing solution. Then we're going to take you through the electronic portion of our solution, and then we're going to give you a clear understanding of the electronic portion of our system so that you can see how it simplifies the integration to the control system. We'll also give you insight into the software component of the solution to allow you to make a decision as to whether you use FuTech software or write your own software or rely on LabVIEW. At the end of the presentation, we will then get into the details of applications on how all three components tie together in a simplified total solution for automation. The LSB200 is the workhorse of our miniature product line. I'm focused on this particular design today for a number of reasons. Performance, 0.1%, nonlinearity, small package size with tight centerline capability. The base design allows for tight centerline locations in applications such as keyboard testing, steering wheel switch testing, where positioning of multiple sensors becomes critical. The mechanical overload stop is also extremely important in automation applications where we have a potential for mechanical overload. This particular design is available in ranges starting down at 10 grams, where in these working ranges the overload stop becomes even more important. Just to explain the mechanism itself, if you look at the current slide, you'll see a female thread on the top of the load cell. We have a matching thread on the bottom, which you cannot see in this image. You attach to those female threads, applying a tension or compression load accordingly to provide stimulation to the load cell. You'll see this particular slide is dimensioned, and I do want to point out the 0.26 inch or 6.7 millimeter thickness. That's the side-to-side centerline dimension that I was referring to earlier. In this package size, as you see, relatively small, and the package size is consistent from the 10 gram range up to the 100 pound range. This next slide gives a better example of the physical loading characteristics for LSB200. But just to kind of recap, again, capacity is down to 10 grams. That is significant. All the more reason that the mechanical stops play an important role in the durability of this particular item. The LSB200 is ideal or optimal for actuator work. It directly supports structures and objects within limits. We've designed it with a high flex cable with a spring strain relief because in most of our automation applications we're under constant movement. We're also introducing minimal mass to the system. This load cell is a very light product, and therefore the additional mass of the load cell to the system is significantly low, thus reducing the unwanted moment in the application. Because of the universal design, that of the female-female thread interface, the LSB200 is a very versatile design. Just a couple examples here in this slide of the accessories that are offered and accessories that clients have provided for this load cell, be it a pulley for wire or thread interface, plates for weighing, male thread conversion, buttons, and of course hooks for weighing. But again, because of its universal design and ease of adaptation, makes it a very versatile product for the user. Because of its easy adaptability, the LSB200 integrates easily into your system and does so in a very cost-effective manner. In summarizing the load cell component of this presentation, we picked the LSB200 from our variety of miniature load cells because of its great nonlinearity, the mechanical overload stops, the versatility of design, and the working ranges from 10 grams to 100 pounds. The last thing I'd like to review is our USB platform. This technology was developed specifically for automation applications, offering very tight nonlinearity extreme resolution and is very responsive with capabilities to make measurements down into the millisecond range. These features are mandatory for the automation applications we support for our system integrators. In looking at the typical platform or the traditional platform, I'm dealing with a setup usually involving a load cell, analog amplifier, and then I'm going to take my signal and I've got to go into my data acquisition solution. I might also have a separate power supply that I need for my load cell. And in many cases, I'm dealing with multiple suppliers for these components. A supplier for the power supply, a supplier for the load cell, and potentially a supplier for the analog amplifier. FUTEC's objective in utilizing USB as our platform was one, to provide a more standardized approach to the marketplace, minimize the number of components to get us from that analog force measurement in this case to the digital world via USB. And I would note that these observations apply not only to our automation clientele, but also our test and measurement clients as well. And this next slide shows a typical approach where we have the load cell and our USB device, obviously a much cleaner solution, fewer components, and a single supplier adaptation. And just to go over some of the key points for our USB solution, offers very high resolution, amazing accuracy, and very high speed. It is a plug-and-play solution with CE approval. We offer RoHS compliance, and in addition to our own software, we offer libraries for the LabVIEW users, and we offer libraries for the programmers as well. So we try and support all three platforms: FUTEC software, LabVIEW users, and programmers. Our objective in using USB technology is to provide a clean, simple downstream solution for the force measurement, getting that information into the digital world as efficiently as possible. We know that eventually we're going into some type of control, and when you look at the FUTEC solution involving the sensor and the USB, it's a very clean, straightforward solution, especially if your application happens to be PC-based. Then we're coming right into your USB with a two-component solution, and of course we offer a software solution as well to make it completely turnkey. Over the last several years, we've grown our family of products within our USB product line. This slide represents some of the key aspects to our USB solution in terms of performance. First of all, you can see we have several devices that we offer, from our USB 215 all the way up to our USB 410. As far as sample rate capability, everything from 300 samples a second up to 4,800. Accuracy-wise, all of them are down at 0.001%. So when you look at your error budget, essentially negligible performance relative to the overall system error budget. Tremendous resolution, offering 16 to 19 bits of maximum resolution, and as far as minimum resolution, 13 to 17. Another key aspect to USB solutions, our testing has shown that we reduce the amount of noise introduced into the system by coming right in with our millivolt signal and going through our A to D versus using an amplified solution and going into an A to D, as would be typical for a PLC environment. I'd also like to point out that when you look at our resolution, we're very specific in indicating noise-free bits. This is based on significant testing done by FUTEC, and we believe this is important because we feel that in many cases this type of information is misrepresented by just presenting bit resolution without taking into consideration noise level influence. In closing, I'd like to say that As with our load cell, where we offer a multitude of load cell solutions, and in this case we selected one particular load cell, the same is true with our instrumentation. We offer many instrumentation packages and solutions. Today we are focused on our USB solution. Next, I'd like to introduce Brandon King. He is our lead electrical engineer at FUTech, and he is going to take us through the details of the software component of this solution. Once Brandon is finished with that, we will then get into the application phase of the program, where we tie all three components together, the load cell, the electronics, and the software, to show you complete solutions for automation applications.
Thanks, John, for that introduction, and thanks to all of you for joining us today. My name is Brandon King. I'm an electrical engineer. I work with FUTech for the software development. So first, let's look at some of the software and developer considerations. First of all, I'd like to say that our USB products lend themselves as a viable option with multiple avenues to take for machine builders, especially when above and beyond is needed. So what are we going to look at today is the hardware setup, which will include the LSB200 and a USB kit as an example. So what are some of the limitations that we should be considering? First, we could look at speed, resolution, reliability, and support. So for speed, we have several USB devices that address higher speed applications, speeds up to 15,000 samples per second. Although there are several limiting factors when you consider the hardware and software components of an automation system, FUTech's USB DLL has been optimized for users of closed-loop systems. Getting the latest reading from the device can be retrieved in 2 milliseconds or less. This provides ample time for a system to be closed several hundred times per second. For resolution, FUTech has USB devices that support high resolution, up to 19 bits noise-free. And reliability. The reliability of USB has improved with the latest operating systems. For example, Windows 8.1 has made improvements to their device enumeration, their USB driver stack, and USB diagnostic tools and debugger extensions. And finally, support. FUTech provides support and tools including FUTech's USB DLL, our USB drivers, several programming examples using LabVIEW or Visual Studio, and more. So now let's look at some of the specific configuration options. There are several platforms that can utilize FUTech's USB solution. First would be Sense-It Test and Measurement. That's an ideal solution for turnkey applications. Supports linearization of up to 16 calibration points. It provides tools such as live graphing and data logging. It also supports up to 16 USB devices. It's also a great tool even if you're developing your own software application, and it can be used for verification purposes. We can also have an ASCII output. So the FUTech USB devices have a continuous streaming output feature. The ASCII output can be used by any software application that can read serial data from the COM ports. A few examples include DocLite, Hyperterminal, PuTTY, RealTerm, and MATLAB. This is an ideal solution for machine builders and integrators that just need an output from the device. Next, there's LabVIEW. FUTech provides a USB DLL that's compatible with LabVIEW, and we also have several examples on our website. Also, you can use Visual Studio, which also supports the use of our FUTech USB DLL. Now let's take a look at Sense-It Test and Measurement. Sense-It provides an easy-to-use application for sensor measurement and for data logging. Sense-It supports all of our latest instruments. We have various instruments that support our entire sensor line. Our instruments can also be used with other sensor manufacturers' sensors, including strain gauge sensors, amplified voltage, amplified current, and encoder pulse outputs. Sense-It also uses the same USB DLL that we provide for use with LabVIEW and Visual Studio. Next, we have a slide that shows an example of a live graph using Sense-It. This live graph plots several different readings at the same time, including tracking, peak, and valley values. As you can see, we support multiple axes for the y-axis. We also have the option to export the data using several different file formats for Excel including XLS, XLSX, CSV files, text files, supporting different formats for different users. Now let's take a look at the FUTech USB DLL. The use of the USB DLL will require some software development experience. The commands used by this DLL have a send and receive type of communication. You have full access to the command set, including the ability to request information from the device, to completely configure the device, and even to calibrate the device. The USB DLL can be used for more advanced integration into your system as well. All of our USB devices also have an ASCII streaming output. The use of the ASCII streaming output is a one-way communication. The streaming output is set to match the sampling rate of the ADC that's on board the hardware. This is useful for applications when only an output is needed. It can be used on several platforms, including the Windows operating system, the Mac OS X operating system, and Linux. The last option that we're going to cover today is LabVIEW. FUTech's USB DLL is compatible with LabVIEW. LabVIEW gives you the ability to use .NET assemblies through several .NET nodes. You can instantiate a .NET object, you can call a method on a .NET class or object, and you can access a property on a .NET class or object. LabVIEW provides all of these features through the functions palette using the connectivity and the .NET extensions. So to summarize, there are several considerations when selecting hardware and software for both automation and system integration. FUTech's USB products provide solutions to these needs, and we're using them in our own software development process. At this time, I'd like to pass it back to John Schnell, and I'll be available during the Q&A session.
Hello again, this is John Schnell, and now we get to the essence of our program today. Tying this all together, as I promised you at the beginning, we'll go through some applications that will give you some great examples on how to apply our technology. I would like to say that the diagrams that we're presenting here are somewhat generic in nature. A lot of that has to do with protecting our customers' proprietary information and also allows us to talk at many different levels. But the first one that we're showing here involves basically medical bag weighing applications, which is very common in our industry, and the LSB200 is the load cell of choice, primarily because of nonlinearity, working range, and mechanical overload stops. In this particular case, I've got two potential considerations. One, the potential to blend pharmaceuticals, where I have a saline bag or a bag with some particular material, and I'm adding custom pharmaceuticals to that to custom manufacture a pharmaceutical for a patient for a specific need. Could be a cancer medication or something like that. In this case, you can see that I've got my sensor, I've got my USB device, and I'm going right back to my laptop computer, running my Sense It software, all very straightforward and simple application. Now, the other application for medical bag weighing involves the distribution of that medication, where I have got the medication and I'm providing the solution to the customer, to the patient, and I'm metering the dispensing of the drug. In this application, we are offering a complete turnkey solution utilizing our load cell, our USB device, our Sense It software, everything running off the laptop computer. The information is being monitored, the graphs are being generated, and the data is being logged to Excel. So in this application, we're able to provide the client a complete solution from one supplier, and again, a very high performance solution. This takes me to my next application, which again is medical in nature. And we do find that a lot of our big applications tend to focus on medical instrumentation. In this case, what we're doing is we're doing a comparison between the force required to activate or move the plunger of a syringe, and then even though it's not shown in exact detail, we're comparing the plunger force to the metered amount of fluid dispensed by the syringe. So we have one load cell looking at plunger force. We have another load cell looking at the fluid being accumulated and measured by the second load cell. Again, in both cases in this application, we have our load cells, we have our USB devices which are capturing the data and sending it into a PC-based solution. And in this case, once again, the Sensit software was utilized to display the data, graph the data, and log all the data to an Excel spreadsheet. An application that is related to the syringe application is fluid injection for imaging work in soft tissue medical imaging, such as MRIs. Fluid material needs to be injected into the soft tissue to get the proper image, and this needs to be done at a specific rate. In those applications, a load cell is used behind the plunger. An actuator is utilized to move the plunger, measuring the force via the load cell. The rate of fluid dispensed is monitored. Information then is sent to the USB. And in cases like that, we're going into usually some type of control where the relationship between the material injected and the imaging start-stop time are correlated. So in closing our first two applications, this gives you some good examples into our medical instrument world, which is one of the key markets that FUTech is heavily involved with. Next, I'd like to take us into the system integration world and discuss an application that's very typical for load cell and USB automation. When you think about typical actuators and the manufacturing process, they're just about everywhere. And as a result of the increased use of actuators, and this might be pneumatic, this could be hydraulic, the level of sophistication is increasing each year. These actuators, which in many cases will have force sensors, speed sensors, displacement sensors embedded in them, are used for a multitude of manufacturing processes such as insertion, crimping, stamping, and others. So once again, when you look at the typical configuration for an analog measurement such as force measurement, and in this case we wouldn't necessarily be looking at something like our LSB200. We'd probably be looking at a higher capacity load cell such as our pancake series or potentially our canister series. So in this last application, we're actually testing a mouse touchpad. In this case, the force happens to be well within the 100-pound maximum of our LSB200, and the client has in fact selected that as their load cell of choice. So in this case, we're going from our LSB200 to our USB device. In this case, the customer is taking the USB information into their own control and providing their own programming solution. In our next application, we really have two industries that we're going to discuss. One, we're back to the medical industry, and in the other application that's very similar, I'm going to talk about animation as it applies to the entertainment industry. In this next application, we're looking at feedback in humanoid robotic applications, or to keep it simple, a robotic arm. A couple applications fall into place. First one is a full robotic solution that was utilizing the LSB200 and providing full robotic capability. In these cases, the millivolt signal is digitized immediately by the USB device, and that information is sent right to an onboard controller, normally proprietary to the end user or the builder. The slide shows the typical test and measurement array involving a PC. That would be part of the setup and programming piece of it, but at the end of the day, as you can well imagine, whether it's a full-blown humanoid robotic solution or whether it was a component such as an ankle foot, the system would be self-contained. Our last application takes us back to the medical world, where we're going to address the control of a catheter specifically used in electrophysiology, peripheral vascular, and cardiovascular applications. In these applications, it's very important to be able to control the catheter as the surgeon inserts the catheter into the patient. This process of controlling the direction and motion of the catheter is done by tension controls of control wires, and the force measuring those wires is done with our LSB 200. In this application, like the others, performance, response, resistance to overload, and noise immunity are extremely important. So once again, we have an application where we're going from the load cell, which is measuring the tension that drives the catheter or directs the catheter through our USB, and in this case, we're going right into the customer's proprietary control where they're taking the USB information and performing their own programming or software environment. So in closing on applications, I think this is the perfect closing point. This application is extremely critical, requires precise results to guide that catheter on its journey to repair the body, and requires a digitized data to allow for proper feedback and control. Although we have focused on one specific load cell today, our LSB 200, as I've indicated earlier in the presentation, any of our strain gauge solutions, or for that matter, any strain gauge solution and other solutions will work with our USB devices. Our USB devices will support millivolt, voltage, current, and also pulsed inputs. So our devices will cover just about any traditional sensor that we'll find in the automation realm. In your USB selection, you're going to be looking at the input, of course, millivolt, voltage, current, as I mentioned a minute ago. The sampling rate required, we maximize our sampling rate depending on the model from 300 to 4800. That is adjustable. And last but not least, resolution. All of the FUTech USB devices are high resolution because we are focused on only the most critical measurement applications. In closing, I'd like to leave you with these takeaways. We do offer an integration solution with minimal components. Once again, load cell, USB, and software from a single source. So we do minimize the number of suppliers in the system integration. Because we focus on the more demanding applications, we're offering high resolution, great accuracy, and very high speed. And then for simplicity's sake, if you look at the last image, it gives you a great representation of how convenient the solution is, where we show the load cell, the USB device plugged into a laptop, and of course our software would be residing on the laptop. So I want to thank you all for your attention today. Hopefully we presented you with some very beneficial information, and it's been a good learning experience. If you do have any questions, we will now move into our question and answer segment. Likewise, you have our contact data should you have any additional requirements or questions at the end of the session. Please contact us. Thank you. The first question: what type of support is provided by FUTech for programmers and LabVIEW users? On our website, we have libraries and examples for Visual Basic, Visual C, and LabVIEW. It should be noted, as with most aspects of our website, this information is continuously updated. Our next question involves sensor compatibility with the USB product line. What other sensors will the USB products support? Our USB products will support any sensor that is a full bridge strain gauge device. We also support sensors that have a plus and minus 10 VDC output or 4 to 20 milliamps. There are also USB solutions that provide signal processing for not only the analog output of our rotary torque sensors, but also for the pulsed encoder output.
Looks like this question is for me. How fast can you go from requesting data to receiving data? Well, the length of time depends on the communication between the hardware and the software, and it can also be affected by the number of processor cores, the amount of RAM, or the number of applications running at the same time. It also depends on the command that's being sent. So, for example, we have a command to request the latest reading from the device. The firmware is scheduled to respond within 2 milliseconds. That means that you can send and receive the command up to 500 times per second. But what about another example? What if you're requesting data and need 15,000 samples per second? Then there's a different command that can be used to request all of the data in the hardware's buffer, which can store up to 60 readings at a time. This means that you'd need to send a request at least 250 times per second, or about 4 milliseconds, to capture all of the data.
This next question is excellent. Can the FUTech USB products be interchangeable with multiple sensors? There are two directions that you can take if we perform a system calibration on the system consisting of the sensor and the USB device. The traceable calibration is performed and the USB device is factory set. They become a match set. If, however, we leave the USB device in the default mode, the output information from the USB device is in millivolts per volt, much like a voltmeter, in which case the scaling can be done within the Sensit software or within your own environment. Our next question addresses the sample rate. Is the sample rate adjustable? Yes. Within the Sensit environment, there are a number of adjustable parameters via pull-down menus, where the user then, in this case, can adjust his sampling rate to whatever setting they desire, up to the specified maximum sample rate for the given device.
Looks like this would be another question for software. What's the response rate for sensors? I'm assuming that what you're referring to is the frequency response of sensors. The frequency response of a sensor will vary from design to design or model to model. To give you an idea, most of our products have a frequency response in several hundred to several thousand hertz. We may have a few designs that exceed 10,000 hertz, but it's not typical. We do have a variety of USB devices that support different sampling rates, from as low as 2.5 samples per second to as high as 15,000 samples per second. Here's a good question. When I think USB, I don't tend to think robust measuring devices. How is this advantageous for machine builders? So if you're referring to the physical robustness of a USB connector, or even the Hiroshi connectors we use on some of our USB devices, then we have other options available, including binder connectors and cables. We also have an upcoming product, the USB 520, that comes in an aluminum closure with binder connectors for the sensor and a standard USB cable for the communication.
Next question. Are there any IOs provided by the USB and Sensit software solution? No, the Sensit software solution is intended for information display and data logging in Excel. Possible IO solutions could be achieved, for example, through use of LabVIEW. Our next question addresses the Excel file. What information is saved to the Excel file? We will automatically save the track value, the peak value, and the valley value. However, this is user selectable. So, for example, if all you are interested in would be the tracking information, you can select just that and send that over. It should also be noted that each data point is date and time stamped for proper evaluation after the test. This brings us to the close of our webinar. First, I want to thank the audience for taking time from your busy schedules to sit in on our webinar. Hopefully, we provided you with some very useful information. And I also want to thank my colleague, Brandon King, for supporting us and taking time to help with our presentation. Once again, if you have any questions or need any additional follow-up support, please let us know. Thank you and have a great day.
Thanks, John, and thanks to all of our audience members for being part of this webinar event. Now, as a sign of our appreciation, One lucky attendee who completes our survey will receive an iPad. So please take a moment to complete our survey, which will appear on your screen at the end of this webinar. You will be receiving an email from us with a link to the on-demand version of this presentation, where you may also access a PDF of this PowerPoint. Again, thanks for taking the time to learn more about automation using miniature load cells and USB solutions. Take care, and we'll talk to you soon.